Hi, this video is about how to find the limit values of an equation like that. So before we start it, let's go over the concept of what is a limit. So I'll give you one example. Let's say I has a hyperbola graph. Let's say the asymptote x equal 1 and the other asymptote is y equal 2. And let's say the graph go like this. Okay. Now we're going to call that f of x. So as you can see, as x approaching infinity, so at x keep going to infinity, you can see look at the black line. You can see they keep decreasing, but they can never reach the asymptote, which is 2. So they can never go below 2. So that's called limit. Limit is something that you just keep approaching, but you will never get that. So the way we write it, we write limit, and underneath here we write limit at x approaching infinity. And you can see here as x approaching infinity, the original equation, f of x equation, will approaching to. So limit of x approaching infinity of the original equation, that's equal to, like that. Okay. Now, here's another example. What about if you has, let's say this time you has a linear line, but you don't include one of the point. So let's say a line go like this, and then suddenly you make a hole here, and then it keep going both direction. Okay, and let's say the original equation for this is y equal 2x plus 3, something like that. And I'm going to say this point here is as 1, all right? So what does this mean? You can see that the function is not defined at x equal 1. Can you make an open hole? So we can represent that using limit. So limit of x approaching 1. Okay, so you can see as the graph approaching number 1 are either on the left side or on the right side. What is the y value approaching? So basically, all you do is just substitute 1 in. 2 times 1 plus 3, which is 5. You can see this point is 1 comma 5. So what that means is when f limit of x approaching 1 of the original equation, which is 2x plus 3, the y value will approaching 5. Okay, so basically you can see to find the value of limit is basically just substitution. If you just do 2 times 1 plus 3, you get 5. Now this is here a few examples of how to get the limit, and I would say the idea is just substitute whatever the value that is approaching to the unknown variable. So here I have a lim of h approaching 0 of 22x squared plus 20xh plus h. So they're telling you that h approaching 0. So you look for, basically just look for letter h and you substitute 0 in. That's pretty much it. So you will have 22x squared plus 20x times h is 0 plus h is 0. Okay, 20, that's become 0, that's become 0. So you would have 22x squared and you're done. For B, lim of h approaching 0 of 3x squared h plus 2h squared over h. So before you substitute in, if you substitute h equals 0 in here, and you know the denominator, you can see you can't have 0 as a denominator. It's just undivided. So what do? We going to simplify first before we substitute in. Okay, so make sure you simplify. But how do we simplify? We factorize the top, and then we can cancel the h out because they all have h. So on the top, we take h out as a common factor. We will have 3x squared plus 2h over h, like that. So the h and the h will go away. So we still have lim of h approaching 0 outside. All right. Then once you've done that, you just get rid of the h. Then now you substitute h equals 0 in. So you will have that's equal 3x squared plus 2 times 0. That gives you 3x squared. Question C, lim of h approaching 0 of tau x. So in here, can you see h approaching 0, but there's no h in the equation, so you would leave at tau x, okay? And same thing for question D, lim of 4 of h approaching 0, x approaching 0, and there's no h in here, so just 4.